Assalamualaikum, Doctor. My name is Farhana. I would like to present my individual project for the subject heuristic technique for combinatorial optimizations. A little bit brief, quick run through on what is the project is about. So, we are going to conduct a meta heuristic algorithm comparison for an assignment problem. So, basically, in this report, I will highlight on the three methods that has been assigned to us to do some kind of comparison. Looking at which are the closest to the optimal solutions and measuring the running time. So the outcome derived from these three variable, basically we run based on the three different parameter, and then out of that three parameter, it will be compared accordingly, for each of the algorithm. So from there, a conclusion will be written by looking into the variations difference of the parameter, how can it contribute to the best solutions and also the running time. So the introductions of this analysis of the project. So we are looking into assignment problem. As you know, assignment problem, we have a set of tasks that need to be complete by a set of resource, and there can be there is a cost and also benefit associated with each potential assignment of the task to a resource. So since this problem is already assigned as a minimized problem, hence I think the objective of this analysis or the study will be to minimize the overall cost. Looking into the data that had been assigned to me, so I'll have a set of 300 resource and 300 set of tasks. So this 300 data will runs again three different methods, which is hill climbing, simulated annealing, and also the taboo search. So by observing the pseudo code from the JavaScript, I can conclude that the section that similar section that has been written, in the script for all these three method will be around these five main pillar. So the first one is looking into a variable declarations. So we have to declare first all the 300 set of tasks and resource from the data sets. And then second will be calculate the solutions. So in calculating the solution, different method will have a different way in calculating the solutions. Third will be neighborhood. From my observation, I can see that three of these criteria and method are having similar neighborhood, which is randomizing, picking up two different job and swap it. So in my analysis, I will maintain the same neighborhood for all three methods. And then will be reset solution. So different method will have different way in resetting the solutions. For example, for simulated annealing, the reset solution will looking into the temperature, right? The accept probability, whether we want to accept the new solutions or not accepting the new solutions. And repeat process, similar in terms of repeating the process, it will determine which best solution will be carried out or will be bring to the next iterations. So okay, so let's just move on to the next slide, which is talking about the hill climbing algorithm and what are the step-by-step approach that has been written in the script. So similar to the previous slide, talking about variables declarations, I think all method is having the same variables declarations, looking into the data that had been given. In calculating different solutions, so from the script, it will first finding the solution representation for this problem, and then from there the objective function is calculated. Third is defining the neighborhood. As per what I mentioned earlier, the neighborhood is a set as random swap of two jobs. And then in order to reset the previous assignment, so when the current solution is less than when the new solution is less than current solutions, then for hill climbing it will declare as new solutions. So when the new solution has been declared, it will set as a new variable to bring out to the next iterations. So that will be a reset process. So in the reset process, it will take the new solutions as a new variables. Then after that, the result will be put out accordingly by showing the number of iterations and also the new objective functions. So this is the parameter setting for hill climbing. So when designing a parameter setting for hill climbing, the parameter setting will revolve around the number of iterations only. So in my parameter setting, my first iteration, I will run for 1500 iteration. The second one will be 2500 iterations. Then the third one will be the extreme number of iterations with 100 and 1500 iterations. So just explaining a little bit on my design of the parameter. So the underlying concept is actually to comprehend, to extend the extent to which variations in iterations can influence the solution. So as you can see, I have a minimum number of iterations to the extreme number of iteration. So this approach is actually designed to analyze the time required for each iterations execution and to assess the extent of the improvement in the results. So looking in, this is the result from the hill climbing analysis. So from what we can see here, the blue bar here is representing the standard deviations, while the purple bar is representing the running time. The line, the orange line here, is representing the average of the solutions from the five number of from five number of the run that we have for each setting. So from here, what we can see is that more iteration leads to a better objective value functions. So as you can see just now, setting 1, I'm having 1500 iterations, setting 2, 2500, setting 3, 110,500 iterations. So when you have higher iterations, it tends to contribute to a better objective functions value or the solutions value, even though the time is significantly higher as compared to setting 1 and setting 2. But looking into the time taken to get the optimal solution here, which is just 83 seconds, is actually acceptable for the results. So here, when you look at the standard deviation, which is represented by the blue bar here, so the lower standard deviation here means the solutions is closer to optimal, which is correct here because the solutions is reducing from 4000 plus to 1000 plus only for setting number 3. So interestingly, when you look into setting number 1 and setting number 3, where comparing the iterations between 2500 and 3500 iterations, see the objective functions value actually improve by 40% only, so boosting the best solution by 11%. So when you look into here, even though there is a small difference between setting 1 and setting 2, but we increase the iteration by 1000, it actually boosts the best solutions by 11% from here. And then when you look into the jump, a substantial jump in iteration between 3500 here, which is setting 2 and setting 3, it is actually able to increase the best solution impressively by 70%. So hence, for hill climbing, I think higher iteration will lead to a better solutions, and we can be closer to the optimal solutions. So next, let's move on to simulated annealing. Looking into the result for simulated, looking into the step-by-step on how the result can be computed using the JavaScript, similar to hill climbing. First will be the variable declaration. Second, similar, looking into the initial solution, finding out the representation first, then calculating the objective function. So in the objective function here, it has been assigned as -1, indicate minimizations problem, and the neighborhood is still having the same swap random of 2 job. And when you look into reset previous assignment, slightly different from hill climbing, so it will first evaluate whether the new solutions is less than the current solutions. If the new solutions is bigger than the new solutions is bigger than the current solution, hence it need to go through the acceptance probability, where we can use the temperature and also the cooling factor to calculate whether we want to accept the new solutions or not. When new solution is accepted, it will declare as the best new variables, and then it will move on, will take the best new variables, move on, bring it to the next iterations. But for simulated annealing, from my observations, I identify that there is a stopping criteria embedded in the script where we're looking into temperature need to be more than 0.0001. So when it reach this number, hence the permutations or they will stop the running. Okay, let's just look into the parameter setting. Interestingly, with simulated annealing, I will look into two different set of parameter or variables in my parameter setting. So the cooling factor for simulated annealing will remain constant for all three parameter setting. So my setting one will have 5,000 iterations with 6,000 temperature, initial temperature. And my setting number two will have a lower number of iteration, which is just 60 with 5,000 iteration. While my setting number three will have different variation where I'm putting higher number in iterations. Sorry, so this is temperature. So higher number of iterations, 6,000 iteration and 50 temperature. So I will change this accordingly. So this is temperature. So when you look into the design, so the underlying concept of this is similar to hill climbing, where we want to comprehend the extent to which variations in iterations and temperature can influence the solutions. So this approach is designed to analyze the time required for each iteration, execution, and to assess the extent of improvement in the results. So when looking at the results, so it's quite interesting because we are using two different parameters for simulated annealing. So the charts indicate how the simulated annealing algorithm speed changes with iteration. So similar iteration is a factor also in simulated annealing. When we increase the number of iterations, so this is actually decreasing. So when we increase it over here, the results is actually better. And then when we combine the temperatures and iteration shows, which is actually shows interesting trend here. So I will evaluate further. For instance, when we use higher temperature with fewer iteration, speed up the algorithm from 709 seconds to 8.6 seconds. So this is higher temperature with fewer iteration. So we have higher temperature in, let me check it. In one of the, I think, higher temperature from 719 to 80 seconds. So it's actually referring to the running time here. So this is referring to the different in higher temperature, right? So you have 700 here, 700, the blue bar referring to the blue 709 second to 8.6 second. So by having this one, by having higher temperature, but fewer number of iterations, we can actually improve the speed. But it will definitely sacrifice the solutions from setting one and setting three here, from 2,668 to 1,030. But when we compare one and two here, by having a lower temperature in setting 2 only slightly changes. So this is having a lower temperature, but in terms of the iterations is the same for setting 1 and setting 2. It shows an incremental of only 0.6%. So I think if we want to solve the problem quickly by using simulated annealing, more iterative, so more iterations will be more practical. So the best solutions, as you can see among these three, setting 1 is having the best solutions, the best solution with 130 solutions value, where the setting is having 6,000 in temperature and with 5,000 iteration, which is the highest among the three. So let's just move on to the next one, which is taboo search. You're looking to taboo search, similar with other algorithm with a set of criteria. It's just that in taboo search, when we declare the variables, the taboo list is set at this stage to 4. Excuse me. And the rest of the step is the same. It's just that when we start this one, also when in the iteration, it will reject the worst iterations. I think, but the rest it looks the same for taboo search algorithm. So in terms of parameter setting here, the parameter setting for taboo search algorithm again is actually similar to hill climbing. I also play around with the number of iteration while leaving the taboo list as a constant. So setting 1, I'm having 2000 iteration. Setting 2, I will have around 200,000 iteration. Setting 3, I'm putting 1 million iterations to see whether, I mean, if we have higher iteration, will we be able to improve the results. So similar to taboo search and also simulated annealing, each setting is actually involve distinct iterations number. We hopefully it should provide a comprehensive analysis on how change in iteration will affect the algorithm performance. So the parameter setting will have from minimum to extreme iteration as per what I explained, maintaining a consistent taboo list length of 4 across all. So let's just move on to the results. Looking into the analysis result, as per expected, higher number of iteration will contribute to a better number of solution. So high iterations in table search actually, but then when we put 1 million here, which is extremely high, I mean, and by just comparing the result, the average result for setting number 2 and setting number 3. Setting number 2 is having 200,000 iteration. Setting number 3 is having 300,000 iteration. The result doesn't really differ, having that much different. But when we compare again, yeah, which I already explained here. So despite just 7% better in solution, the longer iteration setting is 451 slower. So by this one is the running time is definitely higher from 200,000 to 1 million, 451% slower than setting number 2. But when you compare the yield, the outcome that we achieve from these two different settings, it is just able to improve the result by 7%. So in taboo, I think even though higher iteration can contribute to low, but we need to be very careful in setting an extreme number of iteration, because at some level it might not be relevant anymore where the results can be plateau. Okay, this is just to discuss the overall solutions, what happened when comparing each of the method across each other and comparing against the optimal solution, which is represented by this blue bar, by this yellow bar here. Looking into these three method, the best solution is evident that simulated annealing achieved the best solution here with 1015 of number of cost, I think here, and this is just below 389 from the optimal solutions. But from the observations, I think that with by having multiple parameter variations is likely play a significant role in attaining the superior solutions of simulated annealing, because the rest of the algorithm for table search and hill climbing, I just play around with the iteration. But in simulated annealing, I'm playing around with the temperature and also the iterations. I think if we're able to get the best combinations of the temperature and also iterations, and the optimal result can be obtained by using that. Then when comparing the running time here, actually hill climbing is having the lowest running time, which is just 83%. But looking into the result, is still like negative 574 when compared to the optimal solution here, which is 662. So, in conclusions, what I can say from the analysis, more iterations improve results and bring solution closer to optimal. But there is a point where adding more iterations doesn't make a big difference, as per what been, as per what we observe in the table search parameter. Talking about simulated annealing, so when we do the simulated annealing, parameter variation encompassing both iterations and initial temperature adjustment likely contribute significantly to its success. So I think from here it can be concluded that when we want to optimize the result, when we want to compute the best result, we should not just play around with one parameter. We need to play around with multiple parameter just to get the best combination, so that the optimal result can be obtained. So, in conclusions, this analysis we actually highlight, how important parameter setting for algorithm performance. And then simulated annealing with its well-tuned parameter show the best results, as you can see. And then this study revealed that the delicate balance of iteration temperature and runtime in meta-heuristic algorithm. Thank you so much for this. Assalamualaikum.